All right, here we go with the logs unit day 2. Anyone from Algebra 2B, I'm going to ask you, what do you remember about logs? Like, what is a log? Do you remember? Just in just in general terms, what would a log, like, what are you doing when you're doing a log? What are you finding? Kate? No? Nobody's answered the question today, so don't feel bad. All right, you're finding exponents. So really, next year if somebody asks you, hey, what do you remember about logarithms or logs? You can remember the simple thing that logs are exponents. So when you're evaluating a log, which is what we're going to be doing here for the next couple weeks, is we're going to be working with logs. You're working with exponents. That's why yesterday we did all that exponent review, because logs are really just exponents. All right. There's two forms that we're going to talk about here, exponent form and log form. So in exponent form, we would have, like, let's see here, b to the x power equals a. It's just some generic exponent statement, like something to a power equals something, but it's just all variables. It's just generic. So some number b to some number x, any number, is equal to a, right? It's a generic case. If I rewrite that as a log in log form, that's going to look like this. The log of a with the base of b equals x. Yep, that's how you say that. The log of a base b equals x. So when you think about this whole log statement over here that we just made, the log of a base b equals x. What is x over here in the exponent form? It's the exponent. So when you're like doing a log, or you're evaluating something like log of something, you're really just doing an exponent. You're talking about an exponent of something. All right, so logs are exponents. I know it might seem a little weird, but just bear with it. Keep that in mind as we go along through this stuff. And again, it might not sink in until next time you learn about it in college. I don't know, maybe in college, like, oh yeah. All right, well, that's fine. Be patient with the process, okay? There's a thing called a common log. So the common log is a log that doesn't have a base written in. So it's like, you might see it's like the log of a, and there's no base written in there. So you look at it like, I got no base, and there's no base written in there. What do I do when there's no base? What do you do when there's no base? What is it? You remember? Yep, it's automatically a number. Good. Do you remember what number? 10. Nice job, Kate. Kudos to your Algebra 2B teacher, who is? Stop. All right, good job. So common log has a base of 10. That is like, see how it's invisible down there, right? There is no base. Well, really that base is 10. It's just not written in there. But if you're using like one of the basic calculators like this one right here, you can't see this on the video, but it's one of those TI-30s. It's kind of like a scientific calculator, but it's not the top of the line. This has a log button on it, but it's not going to let you type in the base. So the base is always base 10. It's using the common log. All right. If you use the TI Inspires like the ones we have over there, there is a place where you can type in the base and you can change the base right on the calculator. All right, so that's a common log. So you might see some questions that don't have any base. It's actually a 10, right? Okay, moving forward, let's do some evaluating of some nice happy little math book logs. Log of 16 base 4. What does that mean? What is that talking about? What are we gonna do there? Draw a little picture of you. There you are. Your red eyes, evil, mad because you get too much homework and you never get enough sleep, and you're never gonna use this ever in your life. You got a mullet. All right, what are you thinking about when you see this? You're like, oh, here's my thinking bubble. What the heck? What does that mean? What does that mean? What does that mean, log of 16 base 4? What does it mean? Okay. Yeah, that's what I'm teaching you right now. It means 4 to like what power equals 16. See, if this is kind of missing the equals x part, right? If I went back to the previous page and you looked at log form, it'd be like the log of b or log of a base b equals x. Well, that we're like missing the x. So we're looking for like 4 to what power 16. So the value of log of 16 base 4 is 2. Yep, so then to check our work, it's like, okay, how'd you get that? Well, 4 to the second power equals 16, right? And if I change that to log form, that's the log of 16 base 4 equals 2. So when you're doing these logs and you're thinking about them and you're using them and you're evaluating them, you're constantly in your head like probably going back and forth from like writing it as an exponent to writing it as a log, writing it as an exponent, writing it as a log. Next one's a little harder. 25 to what power equals 5? Dylan? 1/2 power. Who agrees with Dylan? Who, hey, by the way, who raised his hand like a polite young man would. Nice job. All right, we got some. Does anybody disagree? Nope, I agree. That's good. It's 1/2. So Dylan has a pretty good little working memory of exponents here. He recognized that 1/2 is the same as square root probably, and the square root of 25 is 5. All right. Maybe some of you aren't as sharp as that with exponents, and so how could you provide a little structure to figure that out? Like, how could you write that out a little bit differently to sort of solve for that? Yeah. No, go ahead. We have patience. We can wait for you. Okay, I think what you're trying to explain is what I'm going to do. So you could rewrite them with the same base. So 25 is actually 5 squared. And so really, when you want to know 25 to what power, you also could say we want to know what 5 squared to what power is equal to 5. So you rewrite both sides of the equation with the same base. And so 5 squared to the x equals 5. What do you do when you have a power to a power? What do I do with the 2 and the x? Do I add them or multiply them? Multiply them. So now what I'm talking about having here is I'm talking about having 5 to the 2x is equal to 5 to the 1. And so Now these are going to be, this equation is going to be true when, because look, it's 5 to the 2x equals 5 to the 1. That's going to be true when the 2x is equal to the 1. So now you could set the exponents equal. When does 2x equal 1? Divide both sides by 2. X is equal to 1/2. So that's a little more of a structured approach. You don't have to do that if you have a pretty good, like, kind of memory of exponents, especially the weird ones like fraction ones and negative ones. All right, next one's not as bad. It's a common log, but it's written in there. So this is like saying 10 to what power is equal to 100? That's 2. So the log of 100 is 2. And that's a common log. If you put that right in a calculator and you go log of 100, enter, it'll say 2. Because 10 to the 2 is 100. If you run into decimals when you're doing these, and by the way, this would be like a no calculator part, so this is all like, hey, we're not doing a calculator, because calculators, you can just type these in, but we want to know, do you understand how to evaluate them? So if you run into a decimal, it's easier to work with it as a fraction, so I just rewrite that. This is the same as 10 to what power is equal to, instead of writing 0.01, I'm going to write 1/100th, because that's what 0.01 is. Question or answer? All right, hold on. How do I take a 10 to a power and make it 1 over something? Negative, right? When you have a negative exponent, isn't that what flips the base? So 10 to the negative 1 power would be what? 1/10. But I want 1/100th, so that means I gotta actually take it as to a negative, and then I gotta square it. So it's gonna be -2. So 10 to the -2 power, the negative part makes it 1 over 10 to the +2, and 1 over 10 to the +2 makes it 1/100th. So this is -2. The next one down here is kind of fun. 5 to what power is 1? Zero. Nice job, Lillian. So we got a 0. 5 to the 0. Anything to the 0 power is 1 except for 0. Okay, how do you feel about that? Good? Any questions? Moving on to the next page. Now we're going to go the other direction. Now we're going to go from exponent form to log form. So now we want to write them as a log. So 7 squared equals 49. When I do this, I write down log. Write down log. Okay. Question? Till under 20. Yeah, I know. Oh, well, that's how much I have for the thing, too. Good, thanks. All right, the 6-minute warning. So I write down log. What's the base? 7, so I write that little base down right there. Okay, what do logs equal? The exponents, right? So which one's the exponent? 2, so I write that 2 there, and then the other stuff I write right there. Log of 49, base 7 equals 2. It looks weird? All right, well, we have 6 minutes here, so there we go. How's that? A little better? So now if you think about it going, I think it's easier for me going the other direction. So now if I think about it the other direction, it's like I start here at 7 to the 2nd power. equals the stuff, right? Is that true? So you go forward, backward. Exponent form, log form, exponent form. What's the next one? Write down log. What's the base? 16. That's down there. Okay, what does it equal? That's the exponent. 3/4, and it is 8. So the log of 8 base 16 equals 4. Do you have to solve it anymore? Yeah. So there's no solving. This is just like exponent form, log form. They're both the same statement. It's just that they're written different ways. Nope, no simplifying it. Okay, this next one's a little different. It's switched around on you. The sides are switched around. So this would be the log of base is 1/5 of 25 equals -2. All right, next page. Some more changing it back the other direction now. So going back the other way, which is the base? 8 to the second equals 64. Boom. Next one, rewrite it as a fraction. 1/2 to the -3rd equals 8. So in my brain, I start there, and I go to there, and then I'm equaling to there. Right? That's how I go. Start at the base, go to the exponent, and that equals the stuff. 2 to the 5th power equals 32. Ka-chow. 8 to the 2/3 power equals 4. Ka-chow. Going too fast? All right. Logs day 1. That'll get us going. I got a practice thing for you. And that's a wrap.